Okay, so remember where we left off. I know I was just as sad as you for us to stop. But we talked about these six, seven, whatever, addition. Not even addition, just regular old number, just counting can't really do, I guess. So we have these seven parent functions, right? Oh yeah, it gets so mad at me. I'm gonna get rid of some of this stuff here, just so we kind of focus on what these graphs actually look like. And we have these seven parent functions, and what we want to figure out is what's going to happen when we take like x squared, let's say, and I take x squared and I add 2 to it. What does that do to the graph, which is this beautiful parabola bowl looking shape? And that's what we're going to look at today. And so we had kind of talked about what these, oh my goodness, translations are. So I'm just going to do a bunch of examples for you. The idea here being, if I have this f of x plus b, so if I take x squared and I add 1 to it, what is that going to do to that parabola? Well, instead of starting at 0, every single number is just going to increase by 1. Not number, excuse me. Every single y value is going to increase by 1. So we're going to look at this graph, or these translations. Remember, if we have a function we add to it, it shifts it up. If we have a function and we subtract from it, it shifts it down. Remember, if we add or subtract from the x's inside that function, then it's going to shift it either left or right, okay? And kind of doing the opposite sign of what we would think, because it kind of changes where your 0 is. That's kind of how you want to think about it. And then how do we reflect about the x or y axis? And if we multiply a function by a number, or if we multiply the x's by a number, what is going to happen? How is that going to change our graph? So look at what I've done, people. Ooh, isn't that fancy? I know. I'm pretty excited about it too. I've got a coordinate system in here. So let's kind of start off pretty simple, and let's see kind of what is going to happen to our graphs when we kind of mess with it. You're getting sick of seeing that when you watch my videos. Example, let's graph this function. F of x equals x squared minus 3. And here's what else I want you to do. I want us to state the parent function and all translations. Okay. So I'm going to do this one first by graphing the parent function, then I'm going to show you what happens when we minus the 3, and then I probably won't do that for every single function after this, but let's graph the parent function. So x squared, right, is my parent function. When x is 0, y is 0. When x is 1, y is 1. When x is negative 1, y is 1. If I take 2 and I square, again, I'm graphing the parent function here, I get 4. Oh, look at this. Isn't this nice having a coordinate system instead of like my own little thing? So my parent function, or the PF on the street, on the math street, I don't know what that means, equals x squared, right? That's my parent function. And now I'm graphing it. And look at how nice this is. Even at 3, I can see I'm at 9. So this, we know, has symmetry about, right, the y-axis. And if I graph this, I get something like this. Amazing. Whoops, what a coordinate system will do for you. Look at that. That's amazing, people. Still a little shaky, but that's okay. So if you look at this, if I do x squared minus 3, if we weren't sure, we can always plug in numbers. So when x is 0, right, f of 0 is going to be 0 squared minus 3, which is negative 3. So I have the point 0, negative 3. I know I have that, okay? And hopefully, again, you don't want to have to do this every single time, but this is what is happening. F of 1, I would have 1 squared minus 3, which is 1 minus 3, which is negative 2. So at 1, I'm at negative 2. Same thing's going to happen when I have negative 1, right? Because f of negative 1, we have a negative 1 squared minus 3. That also equals a negative 2. So at negative 1, I'm at negative 2. And, we could go on and see that when x is 2, f of 2, I'll let you put that in as 1, and likewise when x is negative 2, f of negative 2 is 1. And we could keep going on that way. And that's a valid way to do these, you know, to actually plug in points and plot your graph. However, like when you get to calculus or something, you're not going to have to plug in points every time you want to think about what the graph of a function is. Not even just in calculus. I mean, when we talk about this stuff throughout the rest of this course. So let's see if I can see a pattern and see what kind of happens here. So if I look at, I'm going to plug in 3 really quick and it's going to go to 6. You can verify that for me. I don't know why this goes so shaky. All right, so look at what is happening with this graph right here. I want you to notice a couple of things. As I look at the points from my parent function, look at this point right here. It's going to go down. Oh, yellow isn't working. Nope. How about red? Look at this point right here. Do you see how it's shifted? It's shifted down 1, 2, 3, right? Same with this point right here. It's shifted down 1, 2, 3. It has not shifted left and right at all. Same thing here. 1, 2, 3. Every single point, 1, 2, 3, 1, 2, 3 has been shifted down 3 spots. And that is because we're taking the function values of my original parent function, which was this guy, and we are taking 3 away from each of it. So we've stated the parent function. That's my parent function. I need to state the translations. So what we have done is we have shifted down 3 units. Okay, that's it. And that's my graph. It's not pretty, but it's our graph. So we've stated the parent function and we've stated the translations. All right, so let's do another one. Oh no, it cleared. I did not want to do that. Let's go back here and see if I can. Oh man, that is not what I was expecting to happen with that picture. All right, let's clear this out and see if I can get another picture in there. Sorry about that. Let me grab that guy. Now, hypothetically, this should work. However, I've been having a bit of an issue. Oh, there we go. Great, we got it. Okay, let's do another one. Sorry about that. So same thing, I want you to graph the following function and let's see what's going to happen. So in this case, I want to look at what would happen if I take that negative 3 and I put it with the x instead of the x squared. So I'm actually like putting it into the function. So same idea, I want to graph this. If you can see, your parent function is going to be a squared. I hope that's easy to see. This is basically x squared just kind of messed with a little bit. So that's why my parent function is x squared. Remember my parent function here was this guy, 4, 4, right? And at 3, we're at 9. It has that nice symmetry about the y-axis. And oh, that's a little bit better in that case. I was just kind of kicking myself for erasing it, but I think this might be a little bit better. There's my parent function. And we've already talked about what this minus 3 is going to do. It is going to shift it to the right 3, but let's kind of see why that is true. So if I look at some points here, I'm going to start off with an x value that's going to make this whole thing 0. Okay, so I'm going to start off with x equals 3 because I know that my graph, right, goes through 0 right there. So what if I choose x equals 3? Then I get f of 3 is 0. And then I want to kind of branch out from that 3. So let's go to the right of 3, like 4. So f of 4 is going to be 4 minus 3, which is 1 squared. And then I'm going to go to the left of 3 a little bit. Let's put in 2. F of 2 is going to be 2 minus 3, which is a negative 1 squared, which is 1. Again, why am I not starting at x equals 0 or x equals 1? I want to start at numbers that are going to cause my result of the function to be around 0 and then see kind of what happens there because I know that's the behavior of my parabola. So let's graph some of these points. So look at this point here. This is 3, 0. So 3, 0 is right there. This point here is 4, 1. And this point is 2, 1. We're going to deal with parabolas quite a bit later, and we'll see that it has kind of this cool symmetry. It's not symmetry technically. Well, it has an axis of symmetry, but we'll talk about that later. What about 5? F of 5. If I put 5 minus 3, that's 2. 2 squared is 4. And x maybe of 1. If x is 1, I get 1 minus 3, which is a negative 2, and negative 2 squared is 4. So I have the point 5, 4, and 1, 4. So again, look at what I can do here. 5 up to 4, and if I'm at 1, I go up to 4. And so here's my graph. I'm all shaky again. Don't know. If I put in 6, I think then I'm up at 9. If I put in 1 to the left of 1, I get 0. If I put in 0, I'm up at 9 also. So I get something that looks like this. Okay. Again, it's a parabola. I know it's going to have the same general shape as my parent function, so I know nothing cray is going to... Students tell me cray isn't a cool thing to say anymore. I thought it was cool to say cray cray. I guess not. I guess I need to realize that I am at an age where what I say is just not going to be cool no matter what, because it's me that's saying it. That's all right. So it's pretty clear to see what happens with this function. How do I get this function from my parent function? And I think this one's pretty obvious. Every point that I have is shifted to the right 3 units. Whoops, sorry. This one goes right 3. That one goes to the right 3. Do you see that? 1, 2, 3. So while I know this minus sign is going to want to make you think that it's shifted to the left, it's actually not, because this 0, remember, where did this 0 occur in my original function? It occurred at 0. But now where is the 0 occurring? It's occurring at 3. That's why that guy is moving over. So what are we doing here? What are my translations? We're going to shift right 3. Okay? Okay, I hope that makes sense. Let's look at another one really quick. Whoops. Bring this back in. Now I'm forgetting how I was able to. Okay, so we got that. Sorry about this. There we go. Okay, so let's look at another one. So another example, I want to go back and see what kind of translations we can do. So we talked about up and down. We talked about left and right. Let's talk about a reflection, and then also maybe talk about what if we put this stuff together. That's going to be a good time. So what about f of x equals a negative square root of x? Okay, state the parent function graph, all that good stuff. So what is my parent function? My parent function, I hope you can see if you look at our possible parent functions, right? It doesn't involve just an x. It doesn't involve a square. It doesn't involve a cube. There's no cubed root. There's no absolute value. There's no fraction. What does it involve? Whoops. It involves a square root, right? So that would make sense that my parent function should be a square root. And if we look at that original parent function, square root of 0 is 0. Square root of 1 is 1. The square root of 4 is 2. Square root of 9 is 3. And you get kind of this swoosh looking thing, okay? So look at what this negative x is going to do. Let's plug in some values. If x is 1, then f of 1, right, is saying it's the opposite. So now I'm using this guy, the opposite of the square root of 1. So what's the square root of 1? It's 1. What's the opposite of 1? Negative 1. If x is 4, right? Why am I picking 4? Because that's a perfect square. So I can take the square root of it. I mean, I can take the square root of 2. It's just not a rational number. I don't want to be irrational. Let's stay rational and greater than 0. Positive. Do you get it? Greater than no. I said that to one of my students today and groaned. Which is kind of, I think, what I'm supposed to do as a math teacher, I'm pretty sure. All right, so look at the points we have. I have 1, negative 1. So 1, well, I have 0, 0. I forgot to do that one. I have 0, 0. Then I have 1, negative 1. Okay, then I have 4, negative 2. And then I have 9, negative 3. So look at what this has done. And this is what we said would happen, right? Is we said it would be a reflection about, the x-axis, but I kind of want to talk about why that's true because I care about why. So notice what this guy is doing. My x values are staying the same, but what we're doing is we're taking the opposite of all of my original y values in the parent function. So notice my x values are the same. This point right here was 1, 1, and now what we've done is we've taken the opposite value of the y value. And so that gives me 1 keeps the x value, -1. So that takes all those x's that were positive, if I have positive x's, y's, and if we put a negative in front of that parent function, it flips it and puts it down here. And that is why we get a reflection about the x-axis when we deal with something like that. I hope that makes sense. Okay, yeah, good. Let's do another one with square root of x right here while I have the parent function up. What if we had f of x equals the square root, let's get crazy, of x plus 1. Oh, and I should have stated up here it's a reflection about the x-axis. Plus 3. Ooh. Okay, so what's my parent function? My parent function is going to be y equals the square root of x, because that's what I'm dealing with. Let's look and see what happens here. See this x plus 1 right here? So if we look back at what happens when I do stuff to the x values, it's going to be a shift left or right because it's, whoops, I know, it's the plus. I'm actually going to be moving to the left. So that plus 1, that means I'm going to have a shift left 1. And then what is this plus 3 going to do? This is going to be a shift up 3, right? Because that keeps the same sign. So how are we going to graph this? We're going to graph it very, very carefully. Okay. That was pretty funny, wasn't it? So let's see. I'm going to just grab a different color here. Is that blue going to work? Oh yeah, that blue is beautiful. So what I don't want to have to plug in numbers. I mean, I can, but I don't really want to have to. So let's focus on this black line because the black line is my parent function. I know that my black line goes through the point 0, 0. So where is this point going to go? It's going to shift left 1 and up 3. So it's going to go left 1 and up 3 right there. Let's look at this point right here. Again, left 1 and up 3. This point 4, 2, left 1 and up 3. So I'd be up at 5. And then finally this point, which is 9, 3, is going to go left 1 and up 3, which will be up at 6. So this blue is that shifted. So this guy right here is the blue. Ooh, I love that blue. That's fun. Is that blue line. So again, you can see all of these points shifted to the left 1 and up 3. So we can do multiple translations in one example if we need to. All right, let's do another one. We might as well. What else are you going to do? Okay, let's get a little crazy here. Same thing, I want us to state the parent function, graph it, and state all the translations. So let's get a little wild. What about the opposite of absolute value of x minus 1 minus 2? Actually, let's do plus 2. All right, what's our parent function? So there's no squared, there's no square root, there's no cube root. We have these lines, which means I have the absolute value of x. Remember, one of your parent functions should be one of these, right? So just kind of look at what your function has involved in it. Now, right away, I can see I have some stuff going on. This negative right here, because it's outside of what my parent function would be, is I have a reflection about the x-axis, right? Remember, that's taking all of your y values and reflecting them. So it goes from being, up here to down here, or vice versa. X minus 1, this right here is going to go right 1 or a shift to the right 1. Remember, it's the opposite sign if it's with the x. And then the plus 2 is going to have us go up 2. So let's see what happens. Let's graph I'm going to graph your parent function. You don't have to graph your parent function each time, but sometimes it's useful. If you do graph it, make sure you tell me like which one is your parent function and which one is your solution, right? That was bad. There we go. kind of. Okay. That's not great, but I apologize for that. Let's see if I can find that blue again. I liked that blue. All right, so I'm going to look at just this very first. Whoa, that would have been crazy. I'd let that go. Let's look at this point right here and let's kind of see what happens to that point. Kind of the vertex of my absolute value. So the reflection. So when we look at this, what's going to happen is we kind of want to do order of operations when we're dealing with this. So this is going to, if I wanted to do this all at once, what's going to happen is we're going to work on the inside, kind of the parentheses, and then I'm going to work my way out. So technically what happens is we first are going to shift this guy to the left one. So if I did just kind of a little like idea of what's going to happen, it's going to shift to the left one, okay? Then it's going to have, no, not left. Were you just yelling at me? You should have been. It's going to shift to the right one, okay? Then it's going to do a reflection about the x-axis, which would give me this. And then I'm going to go up too, okay? So my final answer should be, that is a beautiful picture, this one right here, something like that, okay? Because I got to think about order of operations when I'm looking at this. So this guy right here is going to be shifted to the right one. Then it's going to be reflected, but it's not, this isn't going to be reflected, right? Because it is on the x-axis. And then it's going to go up too. Okay, so I hope that makes sense. I'm going to undo this really quick so I can get rid of that circle. Maybe. Maybe not. I guess not. Oh, there we go. Good. All right, so I'm going to go right one, reflect, and go up two. And then I haven't like stretched this or shrinked it. So it's going to continue kind of that slope of 1 over 1 this whole way here. Oh, that's not a great picture, but I hope you get the idea. So I have shifted it to the right one, reflected it, and then moved it up too. It's pretty cool, huh? Yeah, I kind of like it. What if we did do though, what if we did something like f of x equals 3 absolute value of x minus 4, let's say. So again, my parent function here is going to be the absolute value of x. I'm obviously going down 4. I should probably write this in, actually it doesn't matter, but I should probably write this in a order. And then what this 3 is going to do is it's going to be a stretch vertically by a factor of 3 vertically. I'm not going to finish writing that. So look at what we're doing basically. That 3 root, I'm going to just first ignore the minus 4. But if I do 3 times absolute value of x, I'm going to do 3 times 0, which is 0. Here at 1, I'm going to do 3 times 1, which is 3. Instead of having 2, I'm going to be up at 6. Instead of having 3, I'm going to be up at 9. So look at how each of my y coordinates are being multiplied by 3. So that's what we mean by a vertical stretch. Okay, so look at the green versus the black. So I just graphed that 3 absolute value of x with that green, and notice my black is my parent function. So that's what we mean by vertical stretch. If this had been like 1/3 absolute value of x, look, I would take 1/3 of every point right there, and I would get this shrink. That's why we call it a shrink. It kind of compresses it. Let me get rid of that one though. Okay, so this guy gives me that stretch, that vertical stretch, and then I'm going to move this green guy down 4. 1, 2, 3, 4. This point right here would be moved down 4. 1, 2, 3, 4. It's reflected about here because it has symmetry about the y-axis. And then let's see, this guy's gonna be down 4. 1, 2, 3, 4. Sorry, this is getting a little crazy, but that's what we get for something. That final green one right there would be my answer for this whole thing right there. So again, these can be a little tricky, but just, do your best with them. I want to do, maybe 2 more examples and then we'll call it good. So I'd like to do one with the 1 over x, because that can be a little tricky. So I'm not going to be able to do, unless you want to be here for a really long time, which I feel like you probably don't. I'm not going to do an example with every single function. You can look in your book and see more examples of that. But let's look at something like 1 over x plus 2. Okay, so 1 over x, remember, is this one right here, where we have that guy in the first and this guy in the third. So I want to look at what's going to happen. So I know that that plus 2, what do I know that plus 2 is going to do? It's going to shift that whole thing up. I kind of moved that, I didn't mean to. It's going to shift that whole thing up too, but let's kind of see how that's going to work. So if I graph, let's just graph 1 over x. 1 over 1 is 1. Remember, 1 over 2 is a half. 1 over 3 is a third. 1 over 4 is a fourth. And then we kind of talked about how 1 over a half, I would flip it. It'd be 2. 1 over a third would be 3. 1 over 4 would be, 1 over a fourth would be 4. And I'm going to get something like this, okay? And then it's going to do the same thing with my negatives. 1 over negative 1 is a negative 1. 1 over a negative 2 is a negative 1/2. These axes, sorry, make that a little difficult. 1 over a negative 1/2 is a negative 2. So what we're going to end up getting is kind of this nice. Now, if you remember anything from, that doesn't sound very good. Remember from, you know, algebra 2 or whenever you had algebra, that these are called asymptotes. So a vertical asymptote is something that I really can never cross in mathematics. Horizontal asymptotes you actually can cross. Horizontal asymptotes describe the behavior of a function as x gets really, really, really big. However, in this case, we don't ever cross it with this function. So my parent function here, what helps me do these is I really just think about what is my shift going to do to my asymptotes. So I know I'm going to shift up 2. So the y-axis is a vertical asymptote. The horizontal axis is the x-axis is a horizontal one. So when I shift up 2, that's not going to mess at all with my vertical asymptote. That's going to mess with my horizontal one. So everything's going to go up 2. So what I like to do when I graph these is I make a new kind of x-axis. It's basically going to raise my x-axis up 2, and then I'm going to think about where each point is going to go. So this point right here is going to go up 2, that guy, and then I just kind of create myself kind of a new coordinate system where I still have the y-axis, but now this dotted line, I think of that as my new kind of first quadrant. Oh man, I don't understand why this, I really feel like my hand is pretty, I feel like my hand's pretty steady. Apparently it's not, I'm tricking myself. And now I have that guy. And then again, here I kind of have a new quadrant 3, and I'm just gonna move everything up 2, right? And this isn't gonna be perfect because what in life is? Well, mathematics is perfect, but when humans do it, right, it's not always perfect. Oh, that was actually a pretty nice graph. And so if you notice, I just took, oh, aren't those Green River Wolves colors? There you go. Oh, wait, we're not in Green River. Oh, I'm so sorry, Rock Springs. I live in Green River. I shouldn't have said that, huh? I promise I'll do orange and black in the next example. Sorry. All right, so I just shifted up this guy. I shifted it up, 2. Like I said, let me clear this out really quick and let's do another one. I'll bring this in. Okay, so I'd like to do another one like that, but now let's see what happens when we shift it. Okay, so example. Let's do the same thing here, but with f of x equaling 1 over x plus 3, let's say. So what is this going to be? My parent function then, right, is y equals 1 over x. What is that plus 3 going to do? This is going to shift it left, remember? Left 3, okay? So what is that going to do? That's not going to change my horizontal asymptote. That's going to change my vertical. And it's going to take that y-axis basically, and it's going to move it to the left 3. So again, hopefully you're going to get to where you feel comfortable with these functions, and you can actually just kind of start graphing it. So I know my original function goes through the point 1, 1. So I'm just going to shift that over 3. And you can kind of see, right, here's my new, this is kind of my new first quadrant. And so I know it's going to do a little something, something like that. Okay, and then here's my new third quadrant. So again, I know it's going to go like that. And I usually ask you to show me at least 3 points that you know you go through. 1 over x is a little trickier. Like I might ask maybe 2 points that you know it goes through. But notice I shifted that to the left 3. I hope this is all making sense. I know these can be kind of tricky. My big thing that I want you to be able to tell me is, okay, you know, I care that you can graph it. I care that you understand what the graph of that function probably looks like, because that's important. However, I also understand that we have Desmos and we have graphing calculators, and you are probably rarely going to have to graph some of these things by hand, but it's important to understand the behavior of these functions. And so, for example, even if I'm not asking you to graph it, what if I say consider the function, you know, let's do consider the function f of x equals 1/3. Let's actually do a negative 1/3 x plus 1 cubed minus 4. I want you to state the parent function in all translations. So I want you to be able to graph these by hand. I'm going to give you pretty simple ones to graph by hand, you know, similar to what we just did. But all 7 functions are kind of fair game. I'm probably not going to do much with the line, but the other 7 functions are fair game. But I will give you more complicated ones when it comes to just stating the translations. So let's see what happens, and let's kind of talk about the order in which this would happen. So I'm going to work inside the parentheses first. So first of all, what is my parent function? See that cubed? That tells you right there that your parent function is x cubed. Then let's work from our inside out. What is this plus 1 going to do? That's going to shift it to the left 1, right? Then if I work outside here, what is that 1/3? That's going to shrink it vertically. Okay. What is that negative going to do? That's going to be a reflection about the x-axis. Okay, and then finally this minus 4 is going to go down 4. So this is kind of more what I care about. So I could see this and I would know, you know, I know x cubed looks like this. So what do I know? It's going to be shifted to the left 1. It's going to be a little squished down. It's going to be reflected so that it looks like this now. And then the whole thing will be shifted down 4. At least I can kind of get an idea of what my picture should be in my mind, so that eventually when you do get to calculus and you start looking at derivatives and what those derivatives tell you about the function, maybe it makes sense what that derivative is telling you because you know what the graph of the function looks like. All right, guys, that was a long lecture with just examples. I was not able to get through every single example with all of the parent functions. So please, if you have questions on more of these, or if you want more examples, hey, you just let me know. I'd be happy to do it for you.